So the mean value theorem, or MVT, basically helps us connect the average rate of change of a function with the instantaneous rate of change at some point inside that interval, and basically helps us find where those two are equal. So I like to think of this more conceptually. So let's just say you're driving in your car from point A to point B, and let's say your average speed was 60 miles per hour. Of course, sometimes you're going to be slower than that. You might be stuck in traffic. Sometimes you're going to be going faster than that, but at some point in time, your speedometer must have read exactly 60 miles per hour if your average was 60 miles per hour. So this is basically what the MVT tells us. So here's the function, I'm sorry, here's the theorem itself. So basically, if we have f of x, which is a continuous function on the closed interval a to b, and also differentiable on a to b, then we can conclude using the MVT that there's at least one point C such that this holds true. So let's break this down. Over here on the left-hand side, you see we have the derivative, right? So this tells me that I'm looking at the instantaneous rate of change. So this would be basically representing the time when my speedometer was exactly 60 miles an hour. Over here on the right-hand side, we have the average rate of change, right? This is actually just my algebra 1 formula for slope, basically just y2 minus y1 over x2 minus x1. And so basically, this is what the MVT guarantees. Again, that the instantaneous rate of change at some point C is equal to the average rate of change on that closed interval from A to B. All right, so now let's talk about why it's useful for the AP exam. In many of the free response questions, you'll be asked to justify the existence of a point C where the instantaneous rate of change equals the average rate of change over that given interval. All right, let's go ahead and move on to the next topic.